why don't you just stay up here, and I'll just introduce our panelist, who is Joe McMullen, and he's the manager of SimSci product marketing at Schneider Electric. And Joe, why don't you just tell people a little bit about your background and your expertise, so that they know
Thank you, everyone.
kinds of questions to ask you.
Great. So I've spent the last 14 years with SimSci. Previously, Inventus, now Schneider Electric, and I've done everything from technical support to product management and now product marketing. I'm a chemical engineer, so feel free to ask me anything about SimSci. If I can't help you directly, I probably will know the right person to point you to.
Okay. Does anybody have any questions that they'd like to ask or they're thinking about? Okay, we have a gentleman here.
Just to follow up on some of the training initiatives you have, or you guys are actually also looking at, so like for me, I work at Dow Chemical, how could you turn those training modules into actual procedures? So I work within the reliability and maintenance department, and so maybe a video procedure where a guy's about to go into the plant and do a task, so he gets a refresher procedure before he actually commences. So are you guys kind of thinking about that?
Sure. So,
You might want to pull it closer. Pull it closer. Yeah.
sure. So within DynSim, you can record your actions, and within iSim, so you can record your actions as you go through a procedure. So you can then use those recordings to document said procedures. And then, of course, you can videotape an operator going through the procedure as a training method as well.
Okay. Okay, we have another question over here.
Do you find that all of that visual extra stuff is actually taking away from the learning the actual theory? Because the one thing when it's on a 2D diagram, you know, your little two tanks there, we had to learn about height of liquid and how that affected flow out and all of that kind of stuff, versus a visual picture where you learn it by rote, not necessarily the theory.
Yeah, I mean, I can change that around and saying, putting down the equations for a two-tank system, it's in every textbook. Essentially, it's rote anyway. I think, you have to, you can't substitute one for the other. You have to do both. I'm not proposing that you have a control course that doesn't have any theory, doesn't have any of the modeling aspects of it. But I think in terms of putting it in perspective, one of the key, or one of the major complaints that students have had over the last 20 years that I've been at our university is that they get nothing out of the control course. And this is actually taught by somebody who's very, very practical. But I think it's because the examples that are typically given don't relate to a process. It's a piece of equipment. And I think that next step is very important to do that, is to say, okay, you've learned all this. Now let's look at a process and say, okay, what do we talk about open loop response? What does that mean? Is it stable? Is it unstable? What happens when you close the loop? What is cascade control? Why do you use it? Doing the theory for that and actually seeing it implemented in a process and seeing how that can cascade control can actually trim up a variable to where you want it, and getting that feedback, I think, is essential to sort of really understanding the full picture of the control. So it can't be a substitute for it, but again, I think to augment it, it's very important.
Okay, are there any other questions? Oh, okay, see one over here. Oh,
we're using operator training simulators more to train our operators, not necessarily to train engineers. So for the operators, you would not necessarily expect them to go through the theory, but to know the practical consequences of what they are doing. So I think there's definitely a place for operator training simulators in our production units. Unfortunately, we cannot always afford them, so we don't have as many as we would like to have. Now that you have an OTS, how do you maintain it? Because that is a big issue that we have in our production units. I guess you don't have a lot of changes in your process, you just have it as a training software and it stays that way? Or do you adjust it and change it, and how do you maintain it? Just to see a different perspective on how others maybe
Sure.
do that.
In the real world, it's important that you maintain your simulator, maintain that model going forward. Otherwise, as Janice alluded to, it's virtually worthless and it'll be mothballed. So at Schneider Electric, we do offer services that we can come in and help you maintain your model, adjust it. But it is important that you do maintain that. As the process changes, which it will do and adapt over time, it's important to adjust the model accordingly so that they're lockstep. I'm not sure if you have any comments, Richard.
Well, we don't have a process, right? It's not like we have a IGCC plant, so it's just a model as far as we're concerned. I mean, one thing that we have come across recently is changing platforms. So, this was built on a Windows XP platform. The university has stopped supporting anything XP, so we're trying to sort of graduate to Windows 7. But that's not a seamless transition. That takes resources and stuff. So we're working with Schneider to do that. So that's maybe less of an issue of keeping update on the plant, but it's still something that comes up.
We have another question over here. John? No. Wait. Why don't you wait till the mic, in case...
Just to wonder, have you considered using your grad students at the process level to talk about how would you enhance your process? What features might you add to your plant and make that a coursework for them and kind of fold them into the work, if you will?
Yeah, I mean, we actually have an ongoing research program where we have several graduate students sort of using the models there to enhance the control side of things. So we have people who are putting higher level controls on there. We're also doing a project now which we're actually looking at a sort of biomimetic control strategy towards an IGCC plant where sort of we're not using traditional control theory, we're sort of treating the thing as a complicated living being, if you like, and using theory that is more attuned to sort of diagnosis of living systems and seeing if that can be applied to these very complicated processes. So there's all sorts of research going on in that. I don't teach we don't have a graduate level control course at WVU, but we've just brought in several new faculty who I'm hoping are going to introduce those types of courses and graduate level optimization and simulation, and I think they will be making use of the model.
There's another question back.
I guess one of the questions I have is, with all the gaming systems down targeted long before college, like 9, 10-year-old, is academics working with the gamers to put real-life physics, real-life fluid dynamics into those models so that when they go build that roller coaster in Minecraft, the centrifugal force model is correct, so they begin to understand that there is some reality there on how tight that turn can be. So is any of that going on, or that's more curiosity? But
I don't know. I'm not into the gaming side of things. I mean, we have people in our electrical and computer science area who are looking into these things. I know, they typically use a PDE, partial differential equation approach, to sort of capture the physics of the movement, and then it gets embedded in simulations. Of course, the chemical process simulator is all based on at least, what I would call rigorous models. I mean, they're not at the CFD level, but they are, unit operations, they have material energy, equilibrium, chemical equilibrium, reaction kinetics, and it's all unsteady state, although they tend to be one-dimensional transient models. But, the physics, at least within those, are pretty good. On the roller coaster and the, whatever these, other games I don't know, but I presume things like Flight Simulator must have that because, in order to get a realistic feel, I would think they have to be physics-based. But I'm not the person to really respond to that.
But I could see that transition with the technology going into more in that, retraining kids to learn differently. I think it would be an awesome way to go in the future. And I think as the costs come down to some of these technologies and they become more mainstream, we'll see more and more of that. I do think that. Is there another question?
One of the things we found with OTS is not the cost of the OTS, but the development of the model for your process. And I think if there's some standard models, that's fine. But being able to use the OTS for particularly emergency training, which is really what you want it for, to teach your operator what happens when the stuff hits the fan. The robustness of that model is quite demanding. And I'm wondering, maybe what, from a Schneider point of view, what are you guys doing about model development? To add to that, when we struggle with different levels of model, some fairly simple ones that you can kind of walk through, but some more complex ones that we want to use to be able to do engineering comparisons with. So you can, try and pre-engineer and then run it and see if it actually fails or not.
Sure. So I know we're in the process and actually have rolled out several generic models. So whether it's a crude column or a preheat train of various industries, we have a whole set of library of generic models that we've rolled out that can be used for basic training, but then can be tailored, and at least you have a starting point, and it can be tailored to your specific process for more detailed training. So we have kind of tried to lessen that burden of the model building by putting those generic models out there. I also know that we do have different levels of our rigor that we can do, so that you're not always having to do the most rigorous chemical engineering calculations to get the answers. We have the shortcut methods that can get good answers, but they're not the most accurate.
Just to add on, I know a couple of people in my department are doing some work related to this, but there are groups in the country that are looking at developing reduced order models from rigorous transient CFD models. So the problem in a dynamic sense is always trying to maintain the fidelity within the real-time environment. So if you're relying on very detailed multi-dimensional transient models, you just can't get both of those. You can't get that rigor and maintain real time. But a lot of people are working on this where they'll actually take the results and basically use the model as the truth, basically probe the model, establish a reduced order model either through some sort of correlational technique or more sophisticated black box model, and then have that embedded in a bigger model. So you've got a pretty rigorous representation of a specific piece of equipment, say a reactor, in a real-time environment, and it's just using basically the results from a much more complex model to keep it updated and in the real time. So.
You have another question?
Yeah, so in terms of process improvement, let's say you've gone through the exercise of developing this robust model, but could you also use the same simulation to be able to optimize the plant? So that way you got some training going on for the operations, but then for the engineers, could they use the same model to be able to identify running the plant more efficiently?
So our optimization software is actually on a completely different platform, on the Romeo platform. So no, there are translators where you can take the model that you built in DynSim and move it over into Romeo, which is our optimization platform at Schneider Electric. but you wouldn't be able to use the same tool necessarily for your optimization work.
Any other questions? Okay, got some more.
Janice, you gave an interesting statistic. I believe you said it was from Schlumberger, the
6 to 7 years, it was in a report.
6 to 7 years
Yeah.
to 6 to 9 months. Is that to an autonomous employee, one who can make decisions on their own without any guidance on a never encountered problem before? Do you know?
And actually, you could probably
Yeah.
address that, because we were talking about this earlier.
So I can't comment on the 6 to
The 6
9.
to 7 years, but he can comment on that.
So when we recently did a survey last year to our OTS customers, and these responses came from mining customers. And what the problem they had in this specific region was there were so many mining operations, operators would just jump ship every year or so, they said. So you didn't really get enough time after you put in all the time to train the operator. So they used OTS not only as a carrot to dangle to keep people interested, but also to speed up the time. And they said sometimes less than 6 months to get an operator up to speed, but the general majority was under 9 months. Now, that being said, it's a mining operation, so it's not a chemical processing plant facility or a refinery. So I know that there's different levels of operators, but that's what I got from the mining customers, and I do believe it was for an autonomous operator of a mining facility.
Thanks for clarification.
We've had high-fidelity simulators probably for almost 20 years, and ours are good ones in that we can bring a plant up from startup. We can run through all those scenarios rather than just here's kind of steady state and just move around generally around there. So what we've used our simulators for, talk about improving the process, we've had operators go in there and improve startup processes to reduce flaring by factors of 2 or 3 times. Or other procedures will have them, and it's not the engineers who are doing it, it's actually the senior operators. And I would beg differ a little bit about our operators. The best operators are the ones that actually do understand the process and can troubleshoot, and because of that understanding of really how it works, are much, much better troubleshooters than the ones who just learn it kind of by rote and just, oh, here's what I've seen what happens. The ones who actually understand it are the ones that actually can fix those problems that they haven't seen before because they understand how it works.
Okay, are there any other questions? Well, if not, anybody else? I'd actually like to ask a question. If a company wanted to get started on the path to implementing training simulators, operator training simulators, how would they get started?
Well, they can reach out to Schneider Electric or their vendor, and I can put you in touch with the salesman for Schneider Electric. I'm not really sure. I'm kind of on the hot seat here, but so normally it would come in and we do an assessment study, and then the sales and the technical sales people would walk you through the process of how you would want to implement this and how you would want to go about purchasing everything.
And I guess I have one more question. Is what would you like to see in the future in terms of, going forward with training simulators? Would you like, what
Sure.
capabilities, or what are you hearing from people?
So I'm really excited about operator training going forward. Technology, I think we're at a great point technology-wise. The capabilities of gaming systems, which I think really is on the forefront of what ends up in operator training a couple of years down the road, is really advancing at a very quick pace. So you're seeing costs come down. You're seeing the effectiveness in the virtual reality, the visual stimulations are so much greater now that I think it's so realistic that you feel as if you're actually in the process. So I think that as we go along, what I'm really excited to see what is next. I know Janice mentioned smell. I would like to see to feel the movement. So I know way back when, about 15 years ago, 20 years ago, I was so excited when controllers started shaking when there was an explosion in the video game. And now that's absolutely nothing compared to what the technology is today. So I'm really excited just to see what technology comes out for the century going forward.
Okay, and with that, would you like to say a few closing remarks or something that maybe you didn't mention, or, you know, about maybe what you're doing with the knowledge transfer and how that's helping young people? Or...
Me?
Yeah.
Yeah, I'm not sure I have too much to say. I did teach, I also taught a simulation course where I used the DynSim platform and had students actually build up a small process and go through a series of exercises where they actually wrote out startup procedures. It's a fairly simple unit, like it was a deprogrammizer. But, you know, there's enough process equipment in there for them to sort of have to think about. And that concept of, you know, actually what do you do first, how do you get a liquid level in a vessel, et cetera, and then writing the model for that, and then writing the startup procedure, I felt was a very, very valuable exercise. And all the students who went through that, even though it seems like a lot of the things that if you've been in industry you take for granted, when you see students coming out, they really don't understand what's going on in this equipment. I mean, it's easy to say, you know, you look at a diagram and it's obvious, but that is not the case now. I mean, these students do not have a feel for what it is to operate a piece of equipment. And any exposure to the dynamic simulator, I think, is very, very important. So from an education point of view, although it probably is not going to affect anybody in this room, I would like to see more undergraduate education institutions use this as a tool in their coursework, not just as a demonstration, but actually to use it to build models. And I think it's far more valuable than the sort of steady state simulators that we use that are sort of taken as, you know, this is the sort of holy grail of doing the design. Really, a steady state simulator tells you very little. And if we've got more people to look at dynamic simulators and start using those, I think our students will be coming out with a far better appreciation for what it is that's going on in a chemical plant than they do have now. So I guess that's my closing remark.
Okay. Joe, would you like to say something? Maybe talk about the benefits or
Sure.
what you're seeing, why companies purchase training simulators?
Yeah, so like as I referenced that survey, there were so many benefits. So we saw the cost of doing an operator training has come down over the last few years with the technology enhancements. But going from however many years of on-the-job training to train and get an operator up and running to less than a year, that has proven to be extremely important to companies as either workforce retires or they job hop. So it's been very important to make sure that you always have a steady flow of trained operators to run your plant. And that security is one of the best benefits I've seen our customers relay to me for operator training.